A sequence is given by 2 minus 6, 18, and the last term here is minus 486. Find the end term of the sequence. Now from the given sequence, we know that A is 2, R, which is the common ratio, is minus 6 divided by 2, and this will give us minus 3. And the last term L is given to be minus 486. Now, we know that the last term L is given by the expression A r to the exponent of n minus 1. So in this case, we are going to find the value of A is 2 and r is minus 3 to the exponent of n minus 1 equals to the last term, which is minus 486. Now if we divide through by 2, we are going to have minus 3 to the exponent of n minus 1 equals to, this will be minus 243. Alright, so we are dividing through by 2. Now in this case, I also want to divide through by minus 1, so minus 1, so that we are going to left with 3 to the exponent of n minus 1 equals to 243. That's 243. So let's go ahead and express this number at the base to be 3 and the power. We think of the number. So this will be n minus 1 equals to 3 to the exponent of 5. 3 to the exponent of 5 will give us exactly 243. So this number can be expressed in an index form. Alright, so in this case, from the property of indices, when the base are equal, we equate their exponent. So we can go ahead and say that n minus 1 is equals to 5, so that we can move n to the left, to the right hand side, which would be n equals to 5 plus 1, this is minus. Moving it to the right hand side will give us positive. So the value of n is going to be 6. So the end term of this sequence is 6. Let's take a look at another question. The next question we have here is, find the end term of the sequence whose first term is 1 and common ratio is 3 and the sum of the end term is 1903. From the question, the first term A is 1, the common ratio R is positive 3, and the Sn, that is the sum of the sequence, is given to be 1093. Okay, now we know that the Sn is given by the expression A into bracket r to the exponent of n minus 1, all this is being divided by r minus 1 for r is greater than 1. Alright, so now let's go ahead and carry out substitution. A is 1, so we have 1. R is 3, so we are going to use 3 to the exponent of n, and this is minus 1, and this is being divided by 3 minus 1. It should be equals to 1093 divided by 1. Alright, so let's go ahead and simplify this. When we simplify this, we are going to have 1 times any number is the same, 3 to the exponent of n minus 1, all divided by 2 equals to 1903 or 93. Alright, 1093. Okay, so now this is also been divided by 1. Let's cross multiply. When we cross multiply, 1093 times 2 will give us, so in this case we are going to have 3n to the minus 1 equals to 2186. If you cross multiply, that's what we are going to have. Okay. All right, so now let's group like them. So we are going to have 3n to the exponent of n, and this will be 2186 plus 1. So this will give us 3 to the exponent of n equals to 2187. Now we have the 3 to the exponent of n equals to 3 to the exponent of 7. This number can be expressed as 3 to the exponent of 7 in an index form. And also here we have the base equal, so we go ahead and equate their exponents. So in this case, n is equals to 7. So the n term of this sequence is 7. Now, let's take a look at the last question for this section. What is the smallest number of terms of the geometrical series 8 plus 24 plus 72 plus that will give a total greater than 600,000? Now the first term here, a, is 8. The common ratio r will be 24 divided by 8, which is going to give us 3. And we are told that Sn is greater than 600,000. So this will be greater than 600,000. Okay. So now we know Sn, this case is going to give us a r to the exponent of n minus 1, or divided by r minus 1 is greater than 600,000. Okay, and let's go ahead and carry out the substitution. So we are going to have 8 into bracket 3 to the exponent of n minus 1, all divided by 3 minus 1 greater than 600,000. Okay, now when we simplify this will be 8 into bracket 3 to the exponent of n minus 1, all divided by 2. 3 minus 1 is 2, greater than 600,000. Sorry, this should be 2. Now 8 divided by 2 will give us 4, so we are going to have it to be 4 into bracket 3 to the exponent of n minus 1 greater than 600,000. Now if we divide through by 4, we are going to have this to be 3 to the exponent of n minus 1 greater than 150,000. Okay, so this will be 150,000 if you divide 600,000 by 4. Now let's send the 1 to the right hand side. So we are going to have 3 to the exponent of n greater than 150,001. Okay, so in this case, let's take the logarithm of both sides of the expression. So taking the log of both sides, we are going to have logarithm of 3 to the exponent of n is equals to logarithm of 150,001. So that would be 150,001. Now by using the property of logarithm, the n will come down and multiply it by log 3, and this will give us log 150,001. Sorry, this is gonna be 150,001. Now let's divide through by log 3. Dividing through by log 3, n is gonna be equals to log of 150,001 all divided by log 3. And if you do that, you are going to have 10.85. So therefore we can say that the value of n, therefore n is equals to 10.85, which is approximately 11. So if we want to look for the smallest number of terms that this series total will be greater than 600,000, the value of n should be 11.